Welcome back to the next lecture on computer aided manufacturing. We had discussed one of the softwares, that is Delcom Power Mill in the last lecture. Now, I will take you to the 3-axis milling machine where we will use the information that we have fed in the software. So, this is our laboratory demonstration. A machine here, this machine is known as a vertical 3-axis milling machine. The milling machine can be broadly classified into two categories, horizontal milling machine and vertical milling machine. It all depends upon the orientation of the tool. In this, the tool is vertical. Tool is vertical means that movement of the tool is vertical in the z direction, that is why it is known as vertical milling machine. In the horizontal milling machine, the tool direction is towards x direction. So, in this what happens, z axis can go up and down and tool goes up and down, it is vertical to the bed. Specifically, it is vertical to the bed, that is why it is known as vertical milling machine. So, in z axis we have spindle. Spindle provides rotation to the tool and the tool is held in the spindle with the help of a tool holder. We have different kind of tool holders like chucks are there, collets are there, chucks are there, collets are there, so many systems are there. This is held with a pneumatic system. This tool holders use a pneumatic force. The pneumatic system will also show you at the end of the demonstration. So, z axis provides RPM to the tool and it also provides feed in z direction. So, the tool movement is all taken care by the z axis here. This is all again done by the pneumatic system. Going downward is minus z, going up is plus z. So, depth of cut can be definitely controlled by this. So, this is from left to right and right to left, we have x axis, and toward the other wall, towards the end wall of the machine, that is y direction. So, it can be minus x plus x. So, or this is x direction, this is y direction. So, the whole system is set in this way and cutting takes place. So, this is actually the hardware section. As mentioned before, this is integrated with the control panel. This control panel, that is why it is known as CNC, computer numerical control. This panel has knobs, buttons, keys on it that can be used for MDI. MDI is manual data input, and also the initially we have to set the reference for that is used. So, in this we have this turret as well. This is also known as tool magazine. It can hold number of tools, it can hold 24 tools and these tools can be changed while working. As you know, M6 is the MC is miscellaneous command, M6 is tool changing command. We can put tool number like T4M6. The tool at the 4th number in the magazine would be taken up, and this can be done in the program itself. The machine can keep changing the tools while it is working. Like it can do roughing operation in the beginning, then it can pick a profiling tool, then it can pick a ball mill, another finishing tool and do the whole operation in one go. So, this is the beauty of the CNC machine. So, most important point here is referencing that we will see here. So, in the software we had the reference, that is x0, y0, z0, that has also to match with the reference of the machine. So, how do we put that? Now, this table is too big. Because the tool does not know where the workpiece is mounted. The hardware and software has to be integrated, has to come in one plane and one point. This bag is too big. This x direction you can say is next thing you can see, this actually x direction is 650 mm is the size of the job that can be held here, and in y direction it is 500 mm, that is 0.5 meters. In z direction it is around we can hold 400 mm thick block. So, it is the dimensions become 650 by 500 by 400 millimeters cube. So, we have to feed in our computer system or mention in our computer system that where the job is to be held. So, we have mounted our workpiece here, the tool does not know this. The reference with the tool and the job has to happen. So, how do we do this? This we will learn. So, on the right hand side, this black control is our handheld control panel. We can hold it on the hand, also we can mount it on the machine. So, how does this work? Let us see. So, it has x, y, z on it. So, first we click z and z negative, z positive, then we click x, x negative, then x negative and positive both are being set, both are being shown you, then y negative and positive, we can rotate it. So, this is for the manual control. So, this is used for bringing the tool closer to the workpiece. Now, the tool is too close to the workpiece. Now, we need to set 0 0. So, which we just try to put any of the points, try to pick any of the points and try to say that okay, this is the present 0. This corner, okay, this corner or this any point at the edge is 0. So, let us see how do we make 0. So, it is the control system. This is the present location of the tool based upon the present data or the position that is recorded by computer itself. So, we will see here we put x 0, we will put y 0, enter, and x y are put 0. Now, as per this position, now the hardware understand or the software here for the machine understand, and the software for the machine or the hardware understand that this is x 0 and y 0. So, but in our software, in the Power Mill software, what we did, we had put the workpiece center as a reference point. So, we will bring it close to the center. So, I will say for z also y, x and y we have bring it closer. So, how do we do that? So, what we do, one of the ways is we put a piece of paper between the tool and the workpiece. So, slowly we will start bringing our tool down. See, this paper is being rubbed below this, it is stuck. Let us repeat this. The paper is being moved, once it is stuck, it is moved. Now, the tool has just touched the workpiece. Now, this can be made as z 0, and also this is a new reference point. If I say this is as a center, I can put it at x 0, y 0 and z also 0. Now, x, y, z all are 0 here. So, this is our center. So, this is our actual reference point. Also, this is what would be taken by the software, would be understood by the software as well as the reference point. So, this would be also understood by the software as the reference point. Now, the job reference and the tool reference are on the same page. Now, the job center is 0, the same thing is done here. So, we can transfer the same code here on this machine through pen drive, through internet or CD or DVD, there are certain ways. So, whatever our machine control accepts, there are certain ways. So, once the code is transferred, the code opens here. This is the directory, the same file, if you remember, the file name was yes, 3 class. This is the file that is being opened here. So, this is the program that we had made there. So, this is opened here. This is the big program that is opened here, the same program that would be run here. So, also we can make small changes if we need according to the machine setup. We can make certain changes there. For that we have control panel, we have keys here, or the whole keypad is here, and some important keys like these knobs are there, feed override and feed underride also can be set. This is generally known as feed override. So, there are certain controls, MDI manual data input button is there. So, to find the references etc., we can also feed some small codes to see whether the machine is running properly. So, small codes can be written directly on the machine. That is maybe 2, 3, 10, 20, maximum 50 blocks is okay to write with the keypad, but to write the big codes, obviously it is better to use a CAD model and to get the CNC code extracted from that. When I say code, it is NC code extracted from that. So, this is the manual operation. Okay. S is for spindle speed, S is spindle speed. So, if I say spindle speed, okay, I can put some value, it is 1500 RPM. Okay, M03. So, if I try to run that, so the tool has been given clockwise rotation, tool has been given RPM, is given rotation. So, these things we can check definitely manually when we feed it here on the control panel. This is clockwise and anti-clockwise, both the directions are being shown here. Then X movement, Y movement, then Z movement, all the movements can be done manually. Now, let us try to run the machine, and the software, that is software means the power mill program that we generated there. So, let us try to run that program here. So, to run the machine, it is important also to note that the door lock, the machine would only run the program when it is locked. This is also good for the safety precaution. There is a sensor over there, the machine would not run the program unless the door is closed. So, the door top we have the lock here. So, now we can see the tool is engaged, it has started making the pattern that we have fed in the power mill. That was just a CAD model, and the tool is moving. The same thing, plunging happened, now the tool is cutting. Now, step by step the codes are moving, see 0, 9, 50, the codes are moving, the movement is now going on X and Y direction. So, the tool is not moving, the Z axis is almost fixed once the plunge in has happened and cutting has started. Now, X and Y direction are all taken care by the table, machine table. You can see here. See how rapidly tool moves from one point to other in the rapid movement. It jumps up, moves rapidly to the next stage and then comes down. Again, in a milling machine, the depth of cut and RPM is provided by the tool and feed is provided by the stable. And in turning, depth of cut and feed is provided by the tool and speed is provided by the job. So, this is difference between milling and the turning. So, the code is running. So, how the job is moving, the direction is moving, we can see the movement on the right side window here, and on the left side the code is running. Also, one thing is missing here. This is all the run, I won't say dry run, it is a dry machining. Dry run is something when we try to cut air, when we try to move the tool without a workpiece. The workpiece is there, but there is no coolant. That is why it can be called as the dry machining, when no coolant is used. Now, let us switch on the coolant as well. So, manually we have switched on the coolant. So, now this is the coolant. There is a lot of advantages of using coolant. This is also known as flood machining. There are certain ways of machining, flood machining, MQL is minimum quantity lubrication, then dry machining, then near dry machining. This is the generally used method, flood method, in which this rate is maybe 6 liters per minute, from maybe 4 to 20 liters per minute is the flow rate for the coolant. Now, this coolant is also beneficial, it flows through all the slides and different kind of like ball screw is there. So many joints and links are there, it tries to lubricate and it actually lubricates all the joints, those are there across the bed. So, it also takes care of, majorly the coolant is, as the name suggests, is for the cooling of the job. It takes care of the heat that is dissipated during machining. So, there are certain other methods. MQL is one of the methods in which minimum quantity of fluid is just sprayed over the tool. That is also one of the researches that is being taken care by many researchers. So, coolant prevents the tools components here from getting corroded, and also it enhances the tool life because it controls the temperature, and the tool deterioration or the tool wear is minimum. So, M08 is used for switching on the coolant system, M09 is for switching off the coolant system. These things we have already discussed before. So, this is how the machining is happening. So, what we did, we just produced or generated the code there in the Power Mill system. We first made a CAD model, we brought that or imported that CAD model in the Power Mill software. We could have used any of the softwares, any of the CAM software, those are compatible with this Haden-Hin 3-axis vertical milling machine. So, then we imported or then we transferred that code to the machine. That code was made on a computer separately. That computer is linked here through the internet itself. So, then that code is run here. Before running the code, we just made sure that the references for the machine and for the software are same, 000 is same. So, that this has made the machine. Now, while the machining happens, let us see different kinds of cutting tools here. So, these are different kinds of milling tools here. This is the end mill cutter. We have cutting edges at the hand. It is a 4 flute, or we can say 4 edges are there, 4 edges or 4 flute end mill cutting tool. The dia is 10 mm. This is a completely solid carbide tool. In the same way, we have this tool. This is an inserted tool. That was a completely solid carbide tool. It means that in this tool we have solid inserts. So, this is a tool in which the inserts can be put in and those can be shown. There can be locked in using a screw. So, there is sharp tip there, only the inserts get deteriorated, and that can be definitely changed. So, another kind of tool here is this. These are ball milling tools. So, again this is one of them is inserted, one of them is solid carbide tools. Inserted, when I say inserted, the inserts are solid carbide, and when I say solid, is a completely solid carbide tool. Solid carbide tools are obviously very expensive in comparison to the inserted tools. The ball mill is always used for finishing operations, and the tool cutters and these cutters and mill cutters are used for roughing. So, finishing and roughing, this we have already discussed in the previous lecture. So, also while machining, one can observe that whether the machining is going right or not. If any alteration or any change is required, that can be put in here by the operator. He can stop the machine in between and then see whether the machining is going right or not, or what is the state of the machining. Now, we can switch off the machine and also see that what is the state of the machine. So, this is the profile that is generated using any mill cutter. So, this is whatever code we generated there using G and M codes, that is used here to develop or machine this profile here. So, once we have coded properly, once we have put the code in the machine and put the references proper, selected proper tool, selected the proper cooling system, we will get what we needed. So, this is how we do CNC machining. This is one of the very small or very simple machining that has happened. This machine is capable of making profiles as well. Okay, let us see about the pneumatic system here. All these blue pipes that you see here, these gets the air passed through them. So, there are certain gauges here, these are special gauges, actually these are pressure gauges. These controls or these indicates what is the pressure of the air that is passing through them. You can see the 3 pipes 1, 2, 3 going. This is actually back of the machine, these tubes are going towards the front of the machine. These actually give the movement to the slides X and Y, and the switches are activated and deactivated. This number of solenoid valves or solenoid valves are used to switch on and off the supply of air. So, also this is one of the supplies that goes to the spindle. So, with help of pneumatic system as well, with the help of air only, the tool is held, as I just told before. So, this is all the pneumatic system that is there. So many LVDTs are there, those are there, solenoid valves are there, pipes are there, pressure gauges are there. This is all integrated in the system, machining system itself. So, normally machine needs 6 bar pressure, you can see it is a little lesser than this 6. So, it is close to 6 bars. So, this is the pressure that is needed by the machine to work, this specific machine. Now, let us try to see how do we take off and put on the tool in the tool holder. It is very simple, we just click the button and take the tool off. There is a sharp sound of this sound. There is sharp sound of air when we take it off. Also when we put it back in, then also there is sound. So, there is a slot here, this slot has to match with the pin there to put it in, this slot and the pin. So, when we can put it in, this pin goes in here, then there is a sharp sound of kind of sound of the air passing, and it holds the tool pneumatically. So, this is a job that we have got. So, let us try to take this job off, unscrewing the clamps here using a spanner manually. So, these are T slots there on the machine table. Okay. This is the workpiece that is generated. It is exactly the profile that we did there. So, let us try to clean it a little bit. So, this is the profile that we have put it there and we have got it here. So, this is serpentile movement, these are straight movements. So, we did not do finishing, this is just a rough machining cut that we have made using end milling cutter only. We did not use ball milling machine, ball milling tool to finish it. So, just to show you that how does that happen. So, this is the laboratory demonstration on CNC 3 axis vertical milling, and CNC machines are as we all know are capable of producing so many complex surfaces. So, that is also possible. This was a very simple profile that we picked to show you the demonstration on how does CNC machining actually happens. So, this is all about the demonstration on the CNC machines. We will meet in the next lecture. Thank you.